Hello students, we are going to continue our study of geometry today, and our lesson is called Complementary Angles. You can see I have some notes already written down here. If you want to stop the video right now, copy these notes down. That would be good. Then you can press play when you're ready to go. I'm going to be using a playing card again for drawing my straight lines. So you're going to need a straight edge just like this for drawing straight lines. Okay, so it says here complementary angles are two angles whose measures add up to 90 degrees. So we'll be talking about two angles, and when we add their measures, it adds up to 90 degrees. Right now, in number one here, we have just one angle. And we're going to call this angle ABC. We can see that it's a 90-degree angle because it has the little box right there in the corner, which means it's 90 degrees. So we could write a little statement like this. The measure of angle ABC equals 90 degrees. Alright, but now we're going to cut that 90-degree angle into two parts. In fact, I'm going to cut it, try to cut it exactly down the middle. So take your straight edge and see if you can draw a line similar to this one, like that. And we'll call this point D right here. So now we have two angles because we've got this rotation from here to there, and that's going to be angle DBC. But we also have another angle here. If we were to rotate the ray from there up to there, that's angle ABD. So two angles, but we know that those two angles add up to 90 degrees because we started with angle ABC, which is 90 degrees, and we just cut it into two parts. If these are equal parts, that means this one has to be 45 degrees and this one has to be 45 degrees, because 45 degrees plus 45 degrees equals 90 degrees. So what that means is we have two angles that together add up to 90 degrees. That means they are complementary angles. We could write that angle ABD, which is the one with the orange highlight, is complementary to angle DBC. Angle DBC. And we say they are complementary because they add up to 90 degrees. Okay, but number two, we're going to start facing problems where we know what one of the angles is, but we don't know what the other one is. And we'll have to figure out the measure of the other angle. So this time we're going to draw a straight line down and a straight line across, like this. So we've got L, M, N here. And we're saying that this is a 90-degree angle. We'll put our little box in the corner to show that it's 90 degrees. If I'm going too fast for you, you can stop the video and catch up and then push play again. Okay, so we know this is 90 degrees because of the little box in the corner. But if we cut it into two parts, for example, this time we're going to make a small angle and a larger angle. So draw a line similar to that one. And we're going to put point P right there. So this time we're going to say that we have an angle here which is 67 degrees. And then we have an angle here which is X degrees. We don't know what that angle is. Is there a way that we can figure it out? Well, sure there is. We know that together, this angle with X degrees, we could call it angle NMP, added together with the 67 degree angle should add up to 90 degrees since the whole thing is 90. So we can write an equation, just like when we were studying algebraic equations. We can say that X plus 67 equals 90 because this angle plus that angle adds up to the whole 90 degrees. Alright, so then it's a simple one-step equation. We can draw our train tracks, and what do we need to do to get X by itself? Yeah, we need to add a negative 67, or we could subtract 67, right? If we add a negative 67, it's the same as subtracting 67. Add a negative 67 here. So it becomes 90 minus 67 on this side. 90 minus 67, borrow from there, 23. And on this side, the 67s cancel out, so X equals 23 degrees. All right, let's do one more problem. Number 3. Okay, this time we're going to do a line going this way and a line going up on this side, straight up, so that it's a 90 degree angle. So we put our box in the corner to show that it's 90 degrees. W, X, Y. Okay. So we need to cut this into two parts. So we're going to draw a line like this. We'll call this point Z. Okay, so we're going to say that angle YXZ equals 41 degrees. Angle YXZ is 41 degrees. And then we're going to say that angle WXZ, this one, is unknown. We don't know what that is. So angle WXZ equals question mark. We don't know. But we know they're complementary. They have to be complementary because WXY angle WXY equals 90 degrees. So if the whole thing is 90, these two parts have to add up to 90. So let's say, okay, we need to label this. YXZ is our 41 degree angle, and this one we'll call N degrees. We don't know what it is. So how can we set up our equation to figure out what the measure of angle WXZ is? Well, the equation would be adding these two measures together to equal 90 degrees. So we could say that N plus 41 equals 90 degrees. And then we just solve it like a regular equation, drawing our train tracks. We need to get N all by itself on this side. So if I take away 41 here and take away 41 over here, these cancel out. Those are zero pairs. And now N equals 90 minus 41. Let's see. Borrow from there. That's 9, 4, 49. N equals 49 degrees. So we've used the concept of complementary angles to figure out the missing angle. So we could say that angle YXZ is complementary to angle WXZ because they both add up together. They add up to 90 degrees. All right, I'm going to put just a short quiz on a Google form and link that to Google Classroom. So go ahead and take the quiz.